Hello everyone. Previously, we had discussed about the generators and iterators. So today we'll be discussing about the JavaScript engine optimization, nothing but the V8 internals. So if you are familiar with the node, you'll be having certain idea on the V8 engine, right? So V8 engine or the V8 engine optimization, right? So here, let's try to understand first about the V8, and then we will try the same thing with the examples, right? So first, V8 is high performance JavaScript engine basically that compiles the JavaScript into machine code, right? So we need to understand that V8 is an high performance JavaScript engine that basically compiles JavaScript into machine code. So it also optimizes by making by using the techniques like inline caching and the hidden classes. Let's try with the example. Basically, while I said it uses the techniques like inline caching and the hidden classes, we will go with the examples of inline caching and the hidden classes itself. So one I'm telling this one more time that V8 basically it is an high performance JavaScript engine. Basically, it compiles JavaScript into machine code, right? It uses the techniques like for the optimization, it uses techniques like inline caching and hidden classes. So initially, let's uh, try to understand this one with the inline caching. So I'll just come here. Let me give function add of a plus b. Sorry, I'm considering parameter, right? Sorry. Here I'll just give a comma b. This one here it will be, I'll just return. So I'll just return a plus b here, or a minus b, anything you can give. So I'll just give console log. I'll just add the, I'll just make use of the add of 1 comma 2. So this has to give us the output 3, right? So this is nothing but here this is optimized on the repeated calls, right? So this one will be optimized on a repeat I'll just give here repeated calls, nothing but the inline caching. So I'll just give here again console log of add of 3 comma 4. So here the output has to be 7. So I'll just give here output 7. This is optimized on repeated calls. I'm just considering A and B parameters. I'm just showing the examples of the inline caching, right? So here I'm just returning A plus B. So this is optimized on the repeated calls. And the second here I have, no, this has to be console, right? Yeah, here this has to give the output basically 3 and 7. Let's try running the code. Yeah, now we are getting the output 3 and 7. I hope the concept of inline caching is completely clear. So again, I'll tell here what is happening. V8 basically V8 optimizes add, this one. V8 optimizes add by observing the consistent argument type. V8, again I'm telling, V8 optimizes the add by observing the consistent argument type, and subsequent calls reuse compiled code for the faster execution. This one. Subsequent calls reuse the compiled code for the faster execution. Nothing but it is optimized on repeated calls. Here we have to get the output 3 and 7, right? So while we add this one to 1 and 2, this has to be 3, and 3 and 4, this has to be 7. If I try running the code, this will give 3 and 7. I hope this is completely, the concept of inline caching is completely clear. Next, let's try understanding this one with the hidden classes. So I'll just remove this one. Let me give here function. Let's consider something like car. Function name car. I'll just give here parameters make and model. So here let me consider this keyword make. I'll set this one to, sorry, make, and this dot, I'll just set this one model to model. So I hope this is clear. Next, what I'll do, const car1, this one I'll just give here new car of, I can just go for the Toyota, and model I'll just give Camry. So I'll just give here Camry, right? So next, let me take one more this thing. I'll just name this one car 2. Here I'll just give new car of, I'll just consider Honda. Let me give the model Accord, right? So yeah. So after this, let me try logging make and model of the car 1 and car 2. So I'll just, if I just give here console log of make of the car 1, nothing but car 1 dot make, and let me consider the model of the car 2. I'll just give here car 2 dot model. So output that we need to get here is Toyota, this one, make of the car 1, this one we have considered Toyota, right? And model of the car 2 we have considered Accord. So we have to get the Toyota Accord, right, in the output. Let's see. Let's try running the code. Yeah, now we are getting the correct output, Toyota Accord, right? So I'll just explain very quickly. So here V8 uses the hidden classes to optimize the property access. So again, I'm telling V8 engine uses the hidden classes to optimize the property access. And one more thing we have to we need to observe here is objects created by the same constructor share the same hidden class, right? Object that is created by the same constructor share the same hidden class, thus by improving the performance. This is it for the hidden classes. So we had discussed about now we have discussed about the inline caching as well as the hidden classes. So I hope the concept of inline caching and this one hidden classes are completely clear. Nothing but the JavaScript optimization, this one, right? JavaScript engine optimization, nothing but this is V8 internals. So next we will be discussing about the JavaScript design patterns. So when I say design patterns, it might be singleton, factory, observer, etc. These concepts we will be discussing. So for now, this is it. Thanks for watching, guys.